we have discussed the Wheatstone bridge and the balancing condition for the Wheatstone bridge. In this session, we will see application of Wheatstone bridge, that is the meter bridge. Why it is said to be a meter bridge? Because it consists of a wire having the length of 1 meter or the 100 centimeter. Hence, it is said to be a meter bridge. Okay. So, let us start with the first application, that is meter bridge. This is the circuit diagram of meter bridge. In this circuit diagram, X is the unknown resistance, R is the resistance box, LG is the left gap, RG is the right gap, G is the galvanometer, J is the jockey, G is the null point or the balance point, E battery with the EMF E, key and the rheostat. Now we will see the construction of this circuit diagram. The first point is consists of wire having the length 1 meter. So this is the wire AB having the length of 1 meter, that is 100 centimeter. The second point is the meter scale. This wire AB is stretched on this meter scale. Okay, this wire AB is stretched on this meter scale, and the meter scale is fixed on the wooden block. This meter scale is fixed on this wooden block. Okay, there are two L-shaped metallic strips. There are two L-shaped metallic strips, and the ends of the wire, the two ends of the wire are fixed below the L-shaped metallic strip. The ends of the wire, that is A and B, are fixed below L-shaped metallic strip. Here is the central metallic strip which separates these two L-shaped metallic strips. Here is the central metallic strip which separates the two L-shaped metallic strips, which leaves the two gaps, that is left gap and the right gap. Okay. Usually the unknown resistance X is connected in left gap and the resistance box is connected in right gap. The next point is the galvanometer. The one terminal of the galvanometer is connected to the central metallic strip at the point C, and the another terminal of the galvanometer is connected to the jockey, which is represented by J. Now, what is the use of jockey? It is used for the temporary contact with this wire AB. Okay, this jockey is used for the temporary contact with this wire AB. And the last point is the cell with the EMF E. Key and the rheostat are connected between the two ends of the wire, that is A and B. Okay, this is the construction of the meter bridge. Now we have to find out the value of unknown resistance X. For that, a suitable resistance R is selected from the resistance box. Okay, it may be 5 ohm, 10 ohm, 15 ohm, etc. Okay, a suitable resistance R is selected from the resistance box, and this jockey is brought in contact with this wire AB at the various points to obtain the null point or the balance point. The jockey is brought in contact with the wire AB at various points to obtain the balance point or the null point. In this diagram, D is the null point or the balance point. Now, what is mean by null point or the balance point? When this jockey is brought in contact with this wire, then that point galvanometer shows no deflection. It means it remains a constant value. Okay, it remains at constant some value, means it shows no deflection when the jockey is at that particular point. The point is said to be null point or the balance point. So we can write when the galvanometer shows no deflection, that point is known as the null point or the balance point. Galvanometer shows no deflection or it remains constant at that particular point is called as the null point or the balance point. Now consider the length along AD be Lx and length along DB be Lr. Length along AD be Lx and length along DB be Lr. Okay. Now applying the balancing condition for the meter bridge. In the last lecture we have studied the balancing condition for the Wheatstone bridge. This is the circuit diagram of Wheatstone bridge. Okay, there are 4 resistances in Wheatstone bridge, that is P, Q, R and S. And the balancing condition for this Wheatstone bridge is P by Q upon S by R. Okay. Similarly, we can find out the balancing condition for this circuit is X by R is equal to resistance along AD upon resistance along DB. Okay. So X by R is equal to resistance along AD upon resistance along DB. Now consider length of the wire is L, length of the wire is L, area of cross section will be A, and rho is the specific resistance or the resistivity of the material. Consider L is the length of this wire AB, area of cross section of the wire is A, and rho is the specific resistance or the resistivity of this wire. Then we know the formula is rho is equal to R A upon L. Okay, we know the formula rho is equal to R A upon L. Hence we can write from this formula R is equal to rho into L upon A. Rho into L upon A. Okay, we have to find out the resistance along AD and DB. Hence we can write resistance along AD is equal to rho into length of AD upon A. Similarly, resistance along DB is equal to rho into length of DB upon A. Okay, resistance along AD be rho into length of AD upon A, and resistance along DB is equal to rho into length of DB upon A. Okay, but length of AD, we know that length of AD is Lx, hence rho into Lx upon A, and resistance of DB is equal to rho into length of DB be Lr upon A. Okay. Now substitute the value of RAD and RDB in equation number 1. We get X by R is equal to value of RAD upon RDB, that is rho Lx upon A upon rho Lx upon A. Sorry, here it is rho Lr upon A. Now rho get cancelled, A Hence, we get the term as Lx upon L R. So, we get the equation x upon r is equal to Lx upon Lr, and from this equation we can write x is equal to r into Lx upon Lr. Okay. From this equation we can find out the value of unknown resistance x by the formula x is equal to r into Lx by Lr. In this way, we have studied the application of meter bridge. In that, we have studied the construction, the null point and the balance point, and the last one, the formula for unknown resistance x is equal to r Lx by